This is gases video number 3. By the end of this video, you should be able to use a student-constructed manometer to determine the pressure of an enclosed gas. You will need to have your gases video number 3 worksheet and a pencil. As always, this video will be due the next day you have class. Let's start with our student-constructed manometer. First, our manometer is going to consist of a gas collecting tube inside a large beaker. We're going to use water instead of mercury because of the toxic nature of the mercury. We're going to be able to get the atmospheric pressure of our gas from the weather report. So we will literally look that up right off the internet and find out what the atmospheric pressure is in our school at that time. We also have two things happening to the water in the student-constructed manometer at this time. The gases inside the tube are pushing down on the water with a certain amount of force or pressure. We also have, at the same time, atmospheric pressure pushing down on the water inside the beaker. Now, in this case, the pressure of the atmosphere is pushing down with more force than the gases are. So in this case, the pressure of the gases is going to be less than the pressure of the atmosphere. The gases are not pushing the water down as far, and so its pressure is less. Now, to find this difference and to find the actual pressure of the gases, we're going to have to find out this height difference. So we're going to get a ruler and we're going to measure it from the water level inside the beaker to the water level inside the gas collecting tube. This difference we find is going to be in millimeters of water. Water, because we are not using mercury, we're using water. Now the problem is we cannot compare millimeters of mercury and millimeters of water to each other. They have to be matching units. So either the water or the mercury has to be converted. Since so many of our conversions are done with millimeters of mercury, we're going to convert the millimeters of water into millimeters of mercury. We're going to do this by dividing the millimeters of water by 13.6. Now the reason is the following. Mercury is 13.6 more dense than water. So mercury will go 13.6 times less far, or water will go 13.6 times further than the mercury does. So I'm going to divide it to get mercury. Mercury will not go as far. After you do the 52 millimeters divided by 13.6, you're going to get a new height value, 3.82 millimeters of mercury. Now we're ready to do our calculations. Remember, pressure of the gases is less than the atmospheric pressure. So the pressure of the gases is the atmospheric pressure minus this height difference with the matching units. So we're going to bring down our atmospheric pressure and bring over our height difference. And we get 745 millimeters of mercury minus 382 millimeters of mercury. Once again, make sure your units match each other. For our final overall answer, this is rounded by significant figures to 741 millimeters of mercury. Okay, this is what we do when the water level is higher in the gas collecting tube, but sometimes it is higher in the beaker. Once again, atmospheric pressure is going to come from the weather report. Then we're going to go take a look to see where the gas pressure is. The gas pressure is pushing down inside the gas collecting tube. Then we're going to go look at the atmospheric pressure is pushing down inside the beaker. In this case, the gases are pushing down with more force than the atmosphere because the water went lower. So the pressure of the gases is greater than the atmospheric pressure. Now, just like before, we need to know what this height difference is. So we're going to bring over a ruler and we're going to measure the height difference. In this case, our height difference is 75 millimeters of water. Water, not mercury, because we're using water. So we're going to divide this by the 13.6 in order to convert it into millimeters of mercury instead of water. And when we're done, we find that our height difference is about 5.5 millimeters of mercury. We're now ready to do our calculation. Since the gases are greater than the atmospheric pressure, we're now going to add the height difference because we want to get a larger number. Our units now match, so we're ready to plug them in. Once again, see how our units match. When we're done, we get 751 millimeters of mercury. That's rounded by significant figures. And as we can see, the pressure of the gases is a larger number than the atmosphere because it's pressing down more forcefully. So overall, what do we have? The pressure of the gas is equal to the pressure of the atmospheres, plus or minus our height difference, but that height difference has to be converted into millimeters of mercury, so it matches. You do that by dividing by 13.6. If you add or subtract, all depends on whether or not your pressure of your gas should be a bigger number or a smaller number than your atmosphere. Now we're going to be using this information in class to do a student constructed manometer and to investigate Boyle's law, which is going to show us how pressure and volume are related.